Hello, friends. Welcome back to You Can Do TV. A tractor built for muddy fields towed a business jet into a hangar. Another one hauled a 400,000-pound electrical transformer up an icy incline with only 13% wheel slip. Beneath that raw power sits a hidden machine, 800 gearbox parts, 4 independent tracks, and satellite steering down to 2 centimeters. Stick around to hear the price tag on the newest top-spec giant. It will surprise you. Somewhere on a frozen dirt road, a farm tractor is doing something no farm tractor was built to do. It is dragging a 400,000-pound electrical transformer up an incline with a semi-truck pushing from behind. Total load on the hitch, roughly 600,000 pounds. Wheel slip, 13%. Panic level in the cab, probably higher. Now swap the hill for an airport tarmac and swap the transformer for a private jet. A blue farm tractor calmly tows the aircraft into a hangar, nose gear tucked into a tow bar. Wow, a machine built for muddy fields just parked an airplane. So where does that strength actually come from? The strength comes from a place most people picture as a field, but it starts in a factory in Fargo, North Dakota. Raw steel sheets roll in one end, finished four-wheel drive tractors roll out the other. Robots handle 80% of the welds. Each machine is built to a specific customer order. No guessing. Fargo builds a few hundred giants. This next place builds a tractor every 2 minutes. Robotic paint shops, robotic laser cutting, robotic welding, robotic gear machining, all under one roof at India's largest integrated tractor plant. Exported to over 150 countries. 2 minutes per finished machine. Read that again. Now walk into a factory that was designed from scratch, on a bare field, specifically to build high-horsepower tractors. 3 years of planning and construction turned an empty plot in Bavaria into one of the most modern tractor plants on Earth. It handles the 6, 7, and 9 series, machines starting at 130 horsepower and climbing hard. Automated guided vehicles ferry components along the line without a driver. Robotic arms handle the paintwork. Assembly stations plug in engines, drivetrains, cabs, wheels, every step choreographed, every step planned to the second. Here's the part that catches everyone off guard. Every finished tractor gets bolted to a dynamometer and made to earn its badge before it leaves the building. Head to northern France, and the assembly line looks less like a factory and more like an operating room for tractors. Chassis roll down the line while technicians work on engines and front axles at ground level. Dashboards go in. Wiring harnesses snake through cabins. Someone in a full protective suit spray paints a chassis component while the next one is already lined up behind it. Try assembling something the size of a school bus while 10 other school buses are also being assembled around you, on a schedule. That is the daily routine here. Then come the checkpoints. Every tractor ends up on a dynamometer, and every tractor gets an inspection so picky it borders on paranoid. Tires go on last. Down at Mannheim, Germany, you find one of the biggest tractor plants in the world, and it has been building tractors on the same site since the 1950s. Around 3,200 people work here. They build mid-range machines rated between 70 and 220 horsepower. And this is where the story gets interesting for anyone who thought a tractor was just an engine with wheels. Be honest, how many of you thought a tractor was basically a big engine with wheels bolted on until this exact moment? The transmission workshop covers the area of 3 football pitches. Roughly 250 different gearbox parts get stamped, milled, filed, and machined here by both robots and people. A single gearbox in one of these machines contains around 800 parts. Between 150 and 200 finished tractors roll out of Mannheim every day. Engines come from a plant in France. Cabs come from Bruxelles. Everything meets at Mannheim. Then the real trick. A satellite-guided steering system that keeps the tractor online to within about 2 centimeters, cutting fuel and input costs by 15 to 20%. Now shrink the tractor down to the size farmers actually use in orchards and vineyards, and the engineering pressure goes up, not down. Narrower chassis, tighter turning, same demands for reliability. The Agritalia plant in northern Italy handles this end of the market. Specialty machines built with the same discipline as the big boys. Engineers move between CAD stations and the shop floor. Assembly lines feed in engines, axles, transmissions. Wiring, radiators, steering systems drop into place in a set order. Watch a worker install a dashboard in under a minute, then watch the next one show up 30 seconds later, and you start to understand why these plants schedule bathroom breaks. But even a perfect factory hits a wall the moment you ask a bigger question. How does all that engine power actually reach the ground? Between the engine and the wheel sits a gearbox so complex it needs a 3D animation just to explain itself. Gears mesh, clutch packs engage. Arrows show power flowing through the system. That animation becomes real inside a plant in Paderborn, Germany, where a continuously variable transmission is assembled from around 700 individual pieces. 16 fully automated machining stations shape the internal components with the kind of tolerance a rifle barrel would recognize. Every part gets cleaned with compressed air before assembly, the kind of detail that separates a gearbox that lasts 20 years from one that lasts 20 months. Then every finished unit runs 30 minutes on a test bench under load. Failure caught here, not in a customer's field. Roughly 75 kilometers north of Paris, another plant handles a different chunk of the puzzle. Rear axles and multi-speed transmissions built at industrial scale. About 1,000 people work here, on a site covering 43,000 square meters. Annual output, around 25,000 transmissions. The choke point in high-horsepower tractor building has always been the transmission workshop, and the fix here is aggressive machine renewal. 25,000 tons of steel and cast iron move through 105 machine tools every year. Aging equipment gets replaced before it costs quality. Hold on. A single transmission passes through 175 separate checks before it earns a shipping label. That is not paranoia. That is a company that has been called at 2 a.m. by an angry farmer and does not want to repeat. Same joint venture, downstream side. Half-assembled axles and transmission casings move along the line while technicians work on hydraulic lines and internal gearing. Pneumatic tools spin, hoists lift heavy casings, labels get scanned. Every casing carries a paper tag identifying exactly which tractor it belongs to. You cannot build 800 gearbox parts into one working transmission by hoping for the best. You do it by refusing to let a single wrong bolt leave the station. Head east to Qingdao, China, where a plant specializing in transmissions and axles handles both agricultural and construction machinery. Over 200 people work here. Incoming quality control catches bad parts before they enter the line. A coordinate measuring machine inspects large components down to fractions of a millimeter. A dedicated gear measuring center checks tooth geometry. CNC machining stations shape flexible axle components. Planetary carrier subassemblies come together on their own lie. Now jump to the outskirts of Buenos Aires, where axles and transmissions for agricultural machinery get built for the Americas. The site handles the full chain: turning, gear production, machining, heat treatment, and final assembly. A coordinate measuring machine checks a large casting for geometry. Gears get inspected by hand under strong light. A worker in full protective gear paints an assembled axle inside a booth. Finished spare parts get carefully wrapped and boxed with the words "Made in Argentina" stamped on the crate. Zoom right down to the individual gear, and the level of care gets almost obsessive. CNC machines cut teeth under a stream of coolant. A worker measures a gear with a micrometer. Another checks tooth height with a dial indicator. All that microscopic precision eventually has to prove itself inside a moving tractor. And here is the payoff for all that transmission engineering. A machine that can hold itself perfectly still on a hillside without touching the brake. Active stop, power neutral. 4 mechanical ranges, each hitting 100% transfer efficiency. 25 miles per hour at 1400 engine RPM. But perfect power transfer means nothing if the tracks or tires cannot hold the ground. Here is the part every horsepower conversation ignores. You can build a 700 horsepower engine, but if the ground cannot handle it, you have built a very loud paperweight. The quad track answers that with 4 independent positive drive tracks. 5 axles on the ground per side, each conforming to the terrain. Even soil pressure, less compaction, better traction. That combination won it the Machine of the Year award back in 2014, and the design has been quietly refined ever since. Not every farmer wants to buy a purpose-built track tractor, and that is where conversion systems come in. A bolt-on track kit replaces the wheels on an existing wheeled tractor. Result? Reduced compaction, better traction in wet or soft ground, especially in rice paddies and tillage work. Now go narrower. A track system rated as the narrowest in the industry, 12 to 16-inch rubber tracks, designed for row crops where a wide footprint would crush plants. Up to 4 times more contact area than an equal-width tire. Compatible with mid-size wheeled tractors and used for transplanting, spraying, and harvesting. If you have ever watched a tractor sink axle deep in a rice field, you already know why this design earns its price tag. Once the tracks are sorted, the machine itself has to keep the operator productive for 14-hour days. Sight gauges at ground level. A 515-gallon fuel tank. A fast fill system that tops it off in under 4 minutes. No diesel exhaust fluid needed. Then come the numbers that make ordinary tractors look modest. Up to 691 horsepower, a 13.6-liter engine, ballasted weight around 30,400 kilograms. If you owned 5,000 acres and had 72 hours before rain, would you take the wheeled machine or the four-track? And the payoff, a machine whose entire design exists to shove massive power into the dirt. The Quad-Track 715, Tractor of the Year 2025 in the high-power category. Bigger, better, stronger. Field Ops tablet in the operator's hand. Turns out the real strength was never in the engine alone. All that engineering finally meets the one opponent it cannot outsmart: dirt. A four-track machine pulls a cultivator across a Bulgarian field, and the working width is enormous, 12.5 meters in a single pass. That is roughly the wingspan of a small business jet, rolling through soil at working speed. Behind the tractor, dust rises in a wall you could see from the next county. Inside the cab, the operator watches 3 screens: ground speed, fuel burn per hour, and a satellite-guided steering line accurate to a couple of centimeters. Every added meter of working width is another meter the powertrain has to shove through dirt without slowing down. The choke point is right there. Engine can only produce so much torque before the tracks give up grip. Then the soil gets harder and deeper, and the machine has to keep going. Cultivating scratches the surface. Plowing goes 30 centimeters down through corn stalks and packs soil. A multi-bottom plow flips the earth over completely, burying last season's residue. Every bottom digs, lifts, and inverts about a foot of ground, while the tractor drags the whole assembly forward. Take that same power off dry ground and drop it into soaking mud. Now watch what happens. 2 blue tractors are chained together, both trying to move one trailer loaded with harvested produce. Both are stuck. Wheels spin, mud sprays, the trailer does not budge. Wait! Twin machines rated for heavy field work, defeated by wet ground and a full load. No amount of horsepower fixes the moment the tires stop finding traction. Strip away every implement, every attachment, every fancy piece of technology, and what is left is the raw contest between traction, torque, and weight. A rope goes between the tractor and a team of people bracing in the dirt. The tractor pulls, the people slide. Multiple machines, multiple teams, same result. You can watch a farmer haul 10 grown adults across a field faster than they can protest. But raw pulling power is only worth something if the machine actually knows where to go and what to do with it. Modern farming turned the tractor from a puller into the brain of a much bigger system. Behind the machine sits a seeder built with individually mounted opener assemblies, each one carrying its own dual knife and packer. Here is where it gets clever. The fertilizer knife runs deeper than the seed knife, dropping nutrients first. Soil covers the fertilizer. Then the seed knife places the seed on top. A barrier forms between them, preventing fertilizer burn while the seed still gets early access to nutrients. Working widths reach 84 feet. Air cart capacity climbs to 980 bushels. That is a full commercial planting rig moving as one machine. Now add electronics that count every seed leaving the tank. Electric drive meters, section command, variable rate prescriptions. Tank scales weigh the load in real time so the operator knows exactly how many acres remain before a refill. Blockage monitoring catches problems before a whole row goes empty. Peek inside the same machine, and the mystery of how it actually places seeds unravels. A cutaway animation walks through the seed metering system. Volumetric meters portion out seeds with the kind of precision that used to belong to laboratory equipment. Airflow carries each seed through a delivery hose down to the opener at the correct depth. Section command shuts off populations around field contours to avoid double planting. Would you rather trust one operator running a monster rig or 3 drivers each running a mid-sized machine? Where do you come down? Now scale the whole operation up to industrial farming, and the picture gets absurd. Multiple tractors pull massive air seeders across an Australian winter crop plant. Rows appear behind the machines faster than most people can walk. Aerial shots show the field extending toward the horizon. Dust trails mark each planter's path. The machines work in tandem, covering hundreds of acres per day between them. But every piece of power, precision, and coverage comes from one place, a factory that either got it right or did not. Every horsepower this video has covered lives or dies at one final stage, the factory's finishing floor. Start with something most viewers dismiss as cosmetic: paint. A component painting system built into 2,500 square meters of basement space handles parts weighing up to 500 kilograms across more than 20 product families. Each component runs through a 6-stage pre-treatment: degreasing, cleaning, and passivation. Then an automated blow-off zone, then an adhesion water dryer. Passivation is the step that provides long-term corrosion protection and stable paint bonding. 3 years of construction, 61 kilometers of cabling, 73 project members. Also, a tractor's chassis does not rust in 5 years. The cab is the one part of the tractor the operator actually looks at for 12 hours a day, and it gets its own dedicated 200-meter assembly line. Capacity: 100 cabins per day. One finished cab leaves the line every 7 minutes. Around 1,000 individual parts go into each unit: dashboard, steering column, brake system, roof, seats, fenders, all pre-assembled at feeder stations and fed into the main line. The trickiest part is that every cab is unique. Different electronics, different options, different customer configurations. A tracking system watches each cab through 260 checkpoints before it moves on to marry the tractor chassis. Now the finished cab meets a chassis that has been waiting for it, and the whole tractor is finally assembled to spec. Every machine is one of a kind. Over 2,000 parts arrive just in time for its build slot. Production runs on demand. No stockpiles, no guessing. The last stop before shipping is the delivery pass, a final gauntlet under 1,400 lumen inspection lights. Paint quality, cab finish, cleanliness, all reviewed one more time under lights bright enough to expose every flaw. Quality inspectors work through a checklist on tablets. Hood opens, doors open, radiator flap swings. Every maintenance point is verified as accessible. The inspectors are trained to evaluate the tractor through the eyes of the fussiest customer imaginable. Only after passing this does the machine receive its delivery certificate. Even after delivery, quality control does not stop. It just changes uniforms. Season ends, and a technician arrives for a 140-point diagnostic covering every safety and uptime critical system. Belt wear gets measured with a gauge. Coolant gets tested for pH, not just antifreeze level. Batteries get checked with a hydrometer. Torque wrenches hit every wheel bolt. The checklist comes from data pulled from 160,000 connected machines and 2,000 dealer technicians. A weak fan belt today becomes a destroyed cooling system next season, and it costs about 40 times more to fix. Look at what a tractor actually became. It started as a machine to pull a plow. It ended up as a rolling data platform with 800 gearbox parts, satellite-guided steering accurate to 2 centimeters, and 4 independent tracks feeding 700 horsepower into dirt. Here is what nobody talks about in public. Farms are getting bigger, operators are getting rarer, and machines are getting more capable. But the price of a top-spec 4-track tractor now runs past $800,000. That is a house, on tracks, owned by one farm. 20 years from now, will the humans still sit in the cab, or will these giants take orders from a laptop in an office 300 miles away? Tell me where you see this heading in the comments below. Thanks for watching all the way through. If this pulled you in, tap that subscribe button. Plenty more heavy iron coming soon. See you. Take care.